Figure 10.2 Employee Hierarchy UML Diagram. The diagram that you're looking at in front of you is the new version of the employee class hierarchy that we're going to be creating for the purpose of really demonstrating in full the concepts of polymorphism. Our intention here is to create a program in which we can calculate payroll for many different types of employees, and there will be part of that program where we focus on employee specific stuff. For example, the ability to create new objects of the classes salaried employee, commission employee, hourly employee, and base plus commission employee. But we're also going to have a portion of the program that just focuses generically on the concept of an employee. And what we're going to do is make sure that all employees have an earnings method that can be called the same exact way, and that all employees have a two-string method. And then we're going to walk through a collection of employees, and one employee at a time, we're going to output the string representation of that employee and the earnings for that employee in a very generic manner, a polymorphic manner. Employees have many forms and they each get paid differently based on their employee type. So what we want to do is take advantage of the fact that employees have many forms and allow them all to have their own earnings calculation and their own string representation for output purposes in this program. Now, the concept of an employee doesn't really have enough information for us to determine how to calculate the earnings. We need to specifically know which type of employee it is before we can say exactly how to calculate the earnings. So in this hierarchy, you'll notice that the employee class name is placed in italic. That is the UML notation for what we call an abstract class. An abstract class is a class that can be used for inheritance purposes. It can be used to declare variables, but it cannot be used to create actual objects in a program. So its primary purpose is to be the superclass for other classes to inherit from. All the other classes in the hierarchy are what we call concrete classes, classes that we can use to create objects in our program, and all of the classes that we've been dealing with so far throughout the lessons of this video course have specifically been concrete classes, and they were used to create concrete objects. So we're going to begin by focusing on class employee, and then we'll take a look at all the classes in the hierarchy, two of which are already quite familiar to you, the commission employee class and the base plus commission employee class. And what we've done now is we've factored out everything that should be common to all employees from class commission employee, and then created this abstract class employee to house the common data and the common functionality. In addition, we're going to make sure that this class contains all of the different methods that we want to make sure are available for every single class in the hierarchy to enable this polymorphic processing. Now, before we get to the actual source code, we're going to talk more about the earnings and two-string methods. Figure 10.3, Polymorphic Interface for the Employee Hierarchy Classes. Now, as we mentioned in the last diagram, the employee class in this hierarchy is going to be an abstract class. And one of the reasons we're making it an abstract class is that the concept of an employee by itself does not contain enough information for me to figure out how to calculate the earnings for the generic concept of an employee. We need to know which specific type of employee we're dealing with before we can determine how to calculate the earnings. Well, in cases like that where you know you want to be able to do something for every class in a hierarchy, but you don't yet know how to do it, at least as a default way for every class in the hierarchy, what you can do is declare the method that you want all the other classes to define and make that method an abstract method in an abstract superclass. And that's what we're going to do here. This diagram shows you what we intend to implement for the earnings and two-string methods for every class in our hierarchy. And specifically for class employee, you see that for the earnings method, we've put the keyword abstract here. And the reason we're doing that is by itself, the concept of earnings makes sense for every employee in the hierarchy. But as of right now, at the level of class employee, we don't yet know how to calculate the earnings. So what we're going to do is make it abstract in the superclass employee, and that will force all of our subclasses to have an earnings method. And then separately, if the subclasses don't redefine this method, those classes also would have to be declared as abstract classes. So we've got an abstract earnings method, and then we have a two-string method which will be reused by all of the other employee classes' two-string methods, because all employees will have a first name, a last name, and a social security number. We've defined the two-string method of class employee to return a string containing that information. And if you look quickly at the implementations all the way down the line here, you'll see that in every case they include the first name, the last name, and the social security number. Now for a salaried employee, which will be the next class we look at after class employee, a salaried employee gets paid a fixed weekly salary, so the earnings calculation is pretty straightforward. We'll simply need to return that weekly salary. And then the two-string implementation will start with the words salaried employee and will finish up with the actual value of the weekly salary for that employee. For an hourly employee, we're going to pay them by hours worked times their wages, and that will be for hours up through 40 hours in a given week. For any hours over 40, the worker would be paid time and a half. So this if-else statement is going to help us calculate that. And then separately, when it's an hourly worker and we get the string representation, we're going to want to print out the words hourly employee, and we're going to also want to get the hourly wage and the hours worked as part of that string representation. Now, commission employee you're certainly familiar with from our prior examples. Again, a commission employee will be paid based on commission rate times gross sales. And when we do get the two-string representation of a commission employee, we're going to start with the words commission employee, followed by the basic information for all employees, then the gross sales and commission rate values. And finally, base plus commission employee will take the base salary and add it to the commission rate times the gross sales. And then we'll start the two-string representation of a base plus commission employee with the words base salaried commission employee. Then we'll get the information for all employees, then the gross sales, the commission rate, and the base salary value. So you'll see the implementations of all of these methods in the class hierarchy as we now proceed to the employee class hierarchy example.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.